Hello, this video is about biomonitoring of depleted uranium. Biomonitoring techniques have allowed for the assessment of depleted uranium exposure through biological matrices such as blood, urine, feces, hair, and nails. These methods provide insights into recent exposures and are crucial for understanding the health impacts of depleted uranium. In regards to urine analysis, a straightforward method using inductively coupled plasma mass spectrometry has been developed to detect exposure to depleted uranium by analyzing the isotopic composition of uranium in urine. To obtain a stable U-235 signal for calculating the isotopic ratio, a minimum uranium concentration of 14 nanograms per liter is required. Recently, a technique was introduced to differentiate between natural and depleted uranium by measuring and analyzing the gamma-ray spectra of specific samples. Some authors claim that biomonitoring of depleted uranium is applicable only if the amount of depleted uranium in the lungs is more than a few milligrams. Therefore, meaningful measurements can be only made in the case of extremely high exposure. For long-term exposure, where only a small fraction of the amount initially inhaled remains in the lungs, as a consequence of the low specific activity of depleted uranium, lung dosimetry cannot be applied. In such cases, it's more practical to conduct environmental monitoring, reserving individual monitoring for situations where environmental results indicate significant contamination levels and the potential risk of depleted uranium incorporation. Air contamination and atmospheric deposition can be evaluated either by the direct collection of airborne particulate matters using air filters or using suitable air pollution biomonitors. Recent developments in biomarkers for detecting depleted uranium exposure focus on identifying molecular changes that can indicate exposure and potential health risks. Except of widely used genomic techniques, other omic technologies include epigenomics. Research has shown that chronic low-dose uranium exposure can lead to significant changes in DNA methylation patterns, particularly in kidney and gonadal tissues. These epigenetic modifications may serve as biomarkers for assessing long-term health risks associated with depleted uranium. Transcriptomics that investigates transcriptional messenger RNA and post-transcriptional microRNA activities of genes in the presence of depleted uranium. Proteomics studies have identified specific proteins that interact with uranium, suggesting that alterations in protein expression could be indicator of depleted uranium exposure. This method provides insights into the functional state of biological systems affected by depleted uranium. Metabolomics. This approach analyzes metabolites in biological samples to identify changes in metabolic pathways due to depleted uranium exposure. It can reveal specific metabolic deregulations that serve as potential biomarkers for exposure to health and health risk assessment. The metabolism of nicotinate nicotinamide and of unsaturated fatty acid biosynthesis still seem to be ones most affected by uranium. Kidney injury molecules such as KIM1 protein has emerged as promising biomarkers for early detection of kidney injury related to uranium exposure. Its presence in urine can indicate renal damage more sensitively than traditional markers like serum creatinine. Inflammatory markers, elevated levels of inflammatory cytokines such as interleukin-6 may also serve as biomarkers for assessing the biological effects of depleted uranium exposure, indicating systemic responses to potential toxicity. Following, the use of depleted uranium in Bosnia and Herzegovina will be shortly presented. Around 3 tons of depleted uranium were fired during NATO airstrikes in Bosnia and Herzegovina in 1994 and 1995, mainly around Sarajevo. UNEP reported higher radioactivity at several localities where depleted uranium was used. Tank repair facility and ammunition storage in Hadžići, near Sarajevo, is one of them. Biomonitoring study has been conducted in order to assess genotoxic effects in peripheral blood lymphocytes. Now take a break and read following papers. According to the papers from the previous slide, try to summarize the key omissions in the study you were reading about. Specifically address research design, individuals included, number, characteristics, and lifestyle, and confounding factors. Also, here are recommendations for additional readings for this module. Thank you for your attention.